Hey guys, welcome to the Basics of Logarithms video. This kind of just covers everything that's going to be on the Unit 8 quiz, so the first part of the unit of logarithms, and it's key to make sure that you know this material inside and out so that when you get to harder stuff you really can know the basics. So we're just going to start out by looking at what logarithms really are, and the definition here says a logarithm is used to find the power to which a number must be raised in order to get another number. So if we have 2 here, right, so we have 2 log base 2 of 4 equals x. So we basically need to find out to what power does this need to be raised to get to x. To get to 4. So x is going to be the power. So if we have 2 to the x equals 4, right? So if we use this formula that I'm going to teach you if you haven't already learned, but you're basically going to go 2 is the base, and then to the power of whatever's on the right-hand side equals this exponent right here, so the 4. So now if we solve this, we get 2 to the x equals 2 to the second, and then the bases just cancel out so that we get x equals 2. So basically this means that 2 has to be raised to the power of 2 to get to 4. Okay, now if we look at this next example, what does b needs to be raised to get to a? So b to the power of c equals a. So basically this is just the formula that you should always know. The b is going to go on the base, the c is going to be the exponent, and the a is going to be on the other side. So that's something that I want you to memorize, and we can also go backwards. So looking at this next thing, the b is going to be the base, right? So we have log base of b, and then to the a, because that's what we're finding, equals c. So engrave that in your brain, make sure you know that very well, and also make sure that you know the basics of logs that I'm going to discuss next, because you will be tested on specifics, and you definitely want to know those inside and out. Okay, so reviewing the basics of logs, it first says if a base is not specified, it's 10. I'm just going to write out basics of logs. Okay, so if you have in the example, log 100 equals x. So there's no base here, so you really don't know what the base is, right? But you want to assume that the base is 10. So if base is not specified, it's going to be 10. And now we can solve this like anything else. 10 to the x equals 100. 10 to the x equals 10 squared. X equals 2, right? So that's something to remember. If the base is not specified, it's going to be 10. Okay, the next thing is if you add logs, you can combine the term into one log using multiplication. So let's look at the example here. Log 3, so remember we're going to assume the base is 10 then, plus log 4 equals log 12. Okay, so this means that we can basically make it log 3 times 4, which equals log 12. So that's something to remember. And if you subtract logs, it goes the opposite. So if you have log 3 minus log 4, that's going to equal log 3 over 4. Yeah. And the same thing with x and y, you can look at those in the example. And then finally, if a number is outside of a log, you can move it to become an exponent. So this obviously is a choice, and you can move it back. But this is definitely something to remember because there are going to be a lot of things where you have things outside of the logs. So if you have 3 log 3, this is also equal to log 3 to the third. Okay, so this right here moves to become the exponent on the 3, which equals log 81. Okay, so now that we've used the basics of logs, we're going to move on to some examples using the basics of logs. Okay, so looking at our first example here, we can see that the base is clarified, so it's not going to be 10. The base is 3. So we're trying to find what x is, and you can see there are multiple times x shows up. So the first thing that we want to do is we want to combine everything on this side into one log expression so that we can cancel out the logs totally and just focus on the actual terms itself. So in order to combine, we're going to start out by simplifying each log expression. So log base 3 is like the thing above. So the 2 log base 3 of x. We can also make this log base 3 of x squared, right? So we can bring the exponent over here. And then we're going to subtract log base 3 of 4, and that's going to get us log base 3 of x minus 1. Okay, so now if we use our rule of division whenever there's a subtraction sign, right, which there is here, then we know that this is equal to log base 3 of x squared over 4, right? If there's a subtraction, you divide inside of the log, which is equal to log base 3 of x minus 1. Okay, now at this point, because we have a log expression on both sides, these can totally cancel out, and we can just set these terms equal to each other. So we have x squared over 4 equals x minus 1, and now it's just about solving for x. X squared equals 4x minus 4, x squared minus 4x plus 4 equals 0, and then this just becomes a perfect square. X is going to equal 2, which makes sense because if we have log base 3 of 2 squared, that's 4, minus log base 3 of 4 is 0, and log base 3 of 2 minus 1, which is just 1, anything log 1 is going to equal 0. So this is our answer. Okay, moving on to this next example, we're going to see that there's not a log on both sides, right? So there's only 1 over here. So we're still going to want to combine everything on the left-hand side into one thing, but then somehow we're going to have to incorporate this 1 that doesn't have a log in it. So the log is going to stay for a little while longer in this one. So we can make this equal to log base 4 of 25 to the 1/2, right? Because anything out in front becomes the exponent. So 25 to the 1/2 plus log base 4 of x squared, right, moved to the exponent, equals 1. Okay, so now we can combine these. Log base 4 of 25 to the 1/2 times x squared, because it's addition, right, so anything under addition becomes multiplication inside the log, is equal to 1. Now if we want to simplify this, log base 4, 25 to the 1/2 is also equal to root 25, right, so this is just equal to 5x squared equals 1. Okay, so now at this point we can't set anything equal to each other in terms of canceling out logs on both sides. So instead we're going to use the format of logs that we just learned. So we raise 4 to the power of 1 and we set that equal to 5x squared. So 4 to the power of 1 equals 5x squared. And then we divide by 5 on both sides. 4/5 equals x squared, square root, plus or minus 2 over root 5 is going to equal x. Now if we rationalize, we get 2 root 5 over 5 plus or minus equals x. However, you can never have a negative log. So if you have like log base 4 of negative 2, that's going to give you an error in the calculator. So you're not allowed to have that because you can't raise anything to an even power and get a negative, right? So you can't raise 4 to anything and get a negative. It's just not possible. So that's going to give you an error in the calculator. And so the only answer that's going to be able is 2 root 5 over 5, just positive. Okay. Moving on to our next example, we're just going to look at this. Now, obviously here the base is going to be 10 because nothing's clarified, so I'm just going to write that in for now. And also in this example, we're most likely going to set both sides equal to each other and get rid of the logs because there's logs on both sides. So first, we're going to try and combine each log on the left-hand side into 1. So log base 10, and then we're just going to multiply it together because it's addition, of x times x minus 4 equals, now if we have a 2 out in front, we bring that to the exponent, log base 10 of root 12 squared, right, which is going to become 12. So we get log base 10 of x squared minus 4x equals log base 10 of 12. Okay, now at this point we can just totally cancel out the logs because they're on both sides, and we get x squared minus 4x equals 12. X squared minus 4x minus 12 equals 0. And then if we factor this, x minus 6 times x plus 2 equals 0, x equals 6, negative 2. But remember, we can't have a negative log, so the negative 2 is not possible. So x equals 6 is our final answer. Okay, so this is going to be our last example before our examples for finding approximate values of logs. So this example is a little bit different than the other ones because now we have a lot of logs, but they all have different bases. So we can't really combine them in any way unless we find actual values for each of them. So instead, I'm going to set each one of these equal to a variable. So this I'm going to set equal to a, this I'm going to set equal to b, and this I'm going to set equal to c. So a plus b plus c is going to equal x. Okay, so let's first work with our a. So log base 125 of 5 equals a. So now remember the bottom, whatever this is, we're going to need to find what power this needs to be raised to get to 5, right? So if we set that up, we get 125 to a equals 5. So if we want to make these the same base, we can do 5 to the third, right? Because 125 is also equal to 5 to the third. So 5 to the 3a equals 5 to the 1. 3a equals 1 because the 5 bases just cancel out. And then a is going to equal 1/3. Now if we look at b, we know that log base 4 of 16 equals b. Now we need to find out what we need to raise to 4 to get to 16. So that's going to be 2, but let's just make sure. 4 to the power of b equals 16. 4 to the b equals 4 squared. b equals 2 because the bases cancel out. Okay, and now looking at c, log base 3 of 81 equals c. 3 to the c equals 81. 3 to the c equals 3 to the third. c equals 3. So now if we add these all together, we know that a is 1/3. So 1/3 plus 2, because b is 2, plus 3 equals 5 1/3. And so x is going to equal 5 1/3. So let's say you that is an exact value of x. If you plug this into your calculator, that is what you're going to get. And there actually is an error in this, so I'm just going to go back and fix that. So 81 is actually 3 to the 4th. So we're just going to fix that real quick. So c is actually going to be equal to 4. This kind of messes our equation up a little bit. And so then it's going to be equal to 4 down here too. So this is actually 6 1/3. Yeah. Okay. And now we're going to move on to finding approximate values of logs. Okay, so when you're finding approximate values of logs, you're going to do that by having some values of logs. So I got these from my calculator, so I plugged them in and I rounded to 3 decimal places. So that's how I got these. And you can actually find log base 6 without plugging into your calculator from these two. But we're not going to worry about that right now, which is easier if we know what log 6 is. So we're going to start with our first example, log 54. So we are trying to find an approximate value of this, because remember we did round, using what we have above. So that means that we need to split it in two numbers that we have above. So we can do this by taking log 54 log 54 and splitting it up into values that we do have. So I know that 54 divided by 6 is going to be 9. So we can say log of 6 times 9, right? Because 6 times 9 is 54, which is also equal to log base 6 times 3 squared, right? Because 9 is 3 squared. And so now we have all the stuff that we need to be able to solve it. So if we're multiplying something inside a log, that's also equal to adding it. So log base 6 plus log base 3 squared. But we don't know what 3 squared is. So instead we need to bring the exponent out front. So log base 6 plus 2, right? We can bring this out front. Log base 3. And now we do know what this is. This is going to be equal to 0.778 plus 2 times 0.477. Then you put that in your calculator. And not a scientific or graphing calculator, but a regular calculator, like a very basic one. Then you can get 1.732. Okay, so now let's try another example. And I'm just going to erase because I want you to be able to see the values up there still. So if we look at log of the third root of 3. So this one's actually going to be one of our easier ones. Sorry, log third root of 3. This is going to be one of our easier ones because we know what 3 is. So log to the third root of 3 is also equal to log of 3 to the 1/3. Right, so this is fractional exponent instead of in a root. And so then this is equal to 1/3 log of 3, because we can bring the exponent out front. So we know what log of 3 is. 1/3 times 0.477 equals 0.159. So when you're trying to find approximate values, basically the key is just figuring out how to split it up into values that you have. And there are a lot of ways to do that. So you're really just looking for those kind of tricks. Okay, our next example is log of 120. So the key to remember when you're doing things with powers of 10 is that if you take out a power of 10, log to the base 10 of 10 always equals 1. So that's a really nice thing to do. So we can make log of 120 equal to log of 10. And now we're just left with 12, so we can make this times 2 times 6. Which then equals log of 10 plus log of 2 plus log of 6. And then log of 10 is also equal to 1, right? Because this is base 10. So that just becomes 1. And then log of 2 is 0.301. And log of 6 is 0.778. And so if we put that all into our calculator, we're going to get 2.079. Okay, and then looking at our last example, this one seemed like the hardest, but it's not that bad either. So we have log of 20 over root 3. Okay, so we want to split this up, and so we're going to split it up first in the log. So on the top, we can do 2 times 10, right, because we know log base 10 of 10 is equal to 1, over 3 to the 1/2, because we can convert this into fractional exponents. And so now we really have all the stuff that we need to know. So log of 2 plus log of 10, because that's on the numerator and it's separated by multiplication. And now on the denominator, we need to subtract it. We have log base 3 of 1/2. So then this simplifies, because we can bring this out front, right? So we can make this log, or 1/2 log 3. So now this is equal to 0.301 plus 1 minus 1/2 times 0.477, which is also equal to 1.0625. So these aren't really that bad. The key is just to be able to split them up well and looking at what you're given and trying to find values with what you're given. So I hope this helped. Again, I really would go back and look at those basic rules on the front of your worksheet. Make sure you know them really well and make sure that you're not going to get tricked on them because that is part of the test. Okay?